Good afternoon, ladies and gentlemen. Welcome to our IDEA StatiCa webinar. Thank you for joining. And today we will talk about anchoring and specifically how to utilize reinforcement in anchor design. So firstly, let me please introduce ourselves. My name is Jan Valicek. I'm Regional Director here in IDEA StatiCa Asian Pacific in Singapore. And I'm here with my colleague Stefano, Product Engineer. Steph, can you hear us?
Yes. So my name is Stefano. My background is a structural engineer. I have about 5 years of experience designing infrastructures and building projects.
Thank you very much. I will also add that I'm also structural engineer, so you have two structural engineers here, and we also have our colleague Jean who will answer your question together with me. So that's another slide. During this presentation, feel free to ask anything. On the right side, there's a window. So in the question part, put your question, comment, feedback. We will try to answer your questions during the webinar, and some of the questions we will answer at the end of the webinar for everyone. So we would like to hear your feedback and your thoughts about the topic. Let's move to the agenda itself. So what you are going to learn today. So firstly, it will be an introduction about the problem. Then we will talk a little bit more about anchor failure modes and how they are described in design codes. Then we will focus on anchoring problems which are not clearly covered by the code. And then you will see like hands-on workshop by Steph, the complete workflow from a Global FEA software to detail, IDEA StatiCa detail. So you will see how you can get the results of really I would call it tricky anchoring. Of course, a summary at the end and Q&As. So let's jump into the introduction. I'll just turn off my camera so you will have the full screen. Firstly, for those who are not very familiar with IDEA StatiCa, so what do we offer? So we focus on structural analysis and code checks of structural details and critical members. So we have a part focused on steel and concrete. I would say many of you are familiar with IDEA StatiCa connection for steel connection design and anchoring and footing. So we already have a solution how to check anchoring and footing. We also have solution for concrete, for example, concrete walls, cross sections, beams with D regions, and newly also detailed anchorings. So today we will be talking about, let's say, a workflow from IDEA StatiCa connection to detail. So how to cover those situations when your anchoring is failing. Talking about this situation. So what may happen during your design works? This also happened to me. So situations like you need to anchor a column close to the edge of the slab, or you need to anchor a beam to top of the concrete column, or you need to fix a beam to the side of the column, or you have multiple anchorings going from multiple sides of the concrete block. Those are pretty tricky situations which are not very well covered in code, and in many cases it's not too easy because the concrete fails. The concrete failure. This is the issue we have typically. Why we have this issue? Because most of the standard approaches, they assume only unreinforced concrete. So if you go to the code, typically the standard approach and formula says like don't assume any reinforcement. Also, the common software or spreadsheets, no reinforcement included. And if you want to include or utilize the existing reinforcement, or you want to add a supplementary reinforcement, it's not very easy to verify. There are some approaches in the code, we will talk about this later, but it's not straightforward. So before we will start with the content itself and how we can solve this issue, I would like to ask you, how often do you have issues with anchoring design? So please vote. So are you facing these situations often, sometimes, rarely, or you have never faced such a situation? So it will be good to see how often it happens to you. Yeah, so let's imagine that you would like to use some standard software like guilty profits and it fails close to the edge. Yeah, so great to see that votes are coming. 68% of you already voted, so I will give you 5 more seconds. So please, 3, 2, 1, closing the poll right now. And let's share the results. So what can we see? Half of you is having this issue sometimes and 43% often. So, okay. So it's good to hear for us because we are trying to do a solution which covers pains engineers have. So it's very good to see that 43% are facing these situations often and almost half sometimes. So very good. Thank you for this. I'm hiding the polls, and now I will pass it to Steph, and Steph will talk a little bit more about these issues. So Steph is yours right now.
Thanks, Jan, for the introduction. Let me take over the screen. Yep, then I'll full screen it. Okay, yep. So yeah, thanks, Jan, for the introduction. So I will start with the main topic about anchor design. Right, so based on Eurocode and AISC as well, for checking anchoring, right, engineer must make sure that this failure doesn't happen. This failure is divided into 2 parts, which is the tension part and the shear force part. From my experience, right, the governing check usually would be the concrete cone failure for the tension force and the concrete edge failure for the shear force. Right, so this one is a base plate connection which I model in our connection application, and then you can see here that the anchor fails because there is no reinforcement modeled here. And if I see more in detail, you can see that the governing case is actually the concrete breakout failure, which is what I mentioned in the previous slide is concrete cone failure. So what do we do now? Right, so based on the Eurocode and AIC, right? How do you prevent this concrete failure? Basically, you can add what we call supplementary reinforcement in Eurocode. So once you add in this supplementary reinforcement, then the cone failure do not need to be verified. Same with the edge failure, right? But then the supplementary reinforcement, of course, must be designed to take the forces which is not taken by the concrete anymore. Now let's see in the American code or AIC, it's the same thing. Basically, you can add additional reinforcement, but here they call it anchor reinforcement instead of supplementary reinforcement. So the strength of the anchor reinforcement can be used to take the force basically, but the same thing, it must be designed to take the force. Now the following up questions will be, how do you get the force that from the anchor to the rebar? Then you need to design for the rebar. For both Eurocode and AIC, right, if we see in detail, both are suggesting to use strut and tie method to get the force to the reinforcement. Because of this method, right, in my experience, most engineers will just add in additional reinforcement specifically to take in the anchor force. This is done to simplify the strut and tie design process. Yeah. So let's see one way to do it, which most engineers will be doing, which is to add additional reinforcement only for the anchor and then work out the anchor force using a strut and tie and then calculate the AS after you get the force. But then there's another way, which is to make use of the available reinforcement. Why is that? Because in our concrete structures, we already have our reinforcement. So it's a way of material and cost saving that you can use this reinforcement for the anchor breakout as well. But then of course there's some problem for that, which is why it's not used so often. the problem would be like which reinforcement to take the force, right? If we have so many reinforcement, it's a bit hard to figure out which reinforcement we have to take, and then the distribution of the force itself, how many percent goes to one reinforcement, how many percent go to the rest. And then of course, if I mentioned strut and tie, and then how do you do a strut and tie in like this 3D space? I think it will be rather complicated. Then the second problem will be how do you combine the utilization from the anchor and from the internal forces such as bending moment and shear itself. Then we dig deep further, right? Like what if we cannot add any more reinforcement, right? The previous questions for like how to cause some material like to use existing reinforcement, but what if we really cannot add in more reinforcement? What if this like too congested already, you cannot put in more reinforcement? And what if you want to do code checking anchors in existing structures? Of course, the answer would be you have to use available reinforcement in this case. But luckily, the code, for example, in Eurocode, which I show here, Eurocode allows us to utilize available reinforcement which are underutilized to be considered or included as a supplementary reinforcement. But of course, the problem same with the previous slide, like there's no clear instruction how to do that and how to figure out the distribution of the forces itself. Yeah, the next use case that we identify is multiple group of anchors. For example, this is a hoist beam, which is anchored to the slab above and is quite close to each other. This case is not really clearly addressed by the design guide, like how do you solve this type of anchoring problem. So just to recap, basically the problem will be use of available reinforcement, how to figure out the forces, and then second one will be group of closely placed anchors. These scenarios are not well covered by the design code, but then this is where IDEA StatiCa detail can help you in your anchor design, because you can consider the reinforcement inside your anchor design. So basically back to the first slide that I show, connection on application on the left, which is unreinforced concrete. After I export it to our detail application, you can see that the anchorage actually is not failing because we can model in and consider the reinforcement in the anchor design. Right, so that's the end of the theory part. Now I'm going to the workshop part. Basically, I'm going to model a high link way here in Global FEA software, which is ETABS in this case, but you can use many other FEA software and link it to IDEA StatiCa. Then bring it over to IDEA StatiCa checkbot, bring it to IDEA StatiCa connection, and finally bring it to IDEA StatiCa detail 3D and model in the reinforcement. But before that, I think Jan have another poll for you.
Yes, of course, I like polls. So I would like to ask you, so what would you do in your design practice if you are facing the situation then your anchoring design fails? So close to the edge, high tensile force. So let's say before this webinar, so would you add reinforcement specifically for anchors, or would you use available reinforcement, or would you enlarge the concrete block if possible, or modify the base plate geometry, or you don't know what to do? So please vote. What would be your approach to do in such situation? Okay, so more than almost 50% of you have already voted. Nice results. Okay, 70%. So I'm giving you last 5 seconds. So please pick one. And I'm closing the poll right now. And let's see the results. So, okay, 3% don't know what to do. So it's very good to see that 97% of us knows what to do. And then the results are pretty the same. So most 38% of you would add the reinforcement specifically for the anchors, 25% would use available reinforcement, and 34% would just simply enlarge the concrete block or modify the base plate geometry. So, and in many cases, and Steph will show you, this is really unnecessary step, just wasting the material in many cases. And the first two, of course, this is what Steph was talking about. It's well described in the, or well, it's described in the code, but not very well, and it may not be super straightforward. So thank you for your votes. And now, Steph, can you please show us what's the workflow in IDEA StatiCa?
Yep, sure, Jan. So I will just turn off my slides and show tabs on my screen. So basically, this is the structure that I am designing. I have run the model. You can see that the internal forces is already there. Basically, what you need to do to link with our software is just add our plugin inside tabs, and then you can just click this button. But for other softwares, the steps will be similar. Just need to go to our website, ideastatica.com/bim. Now it's checkboard is opening on my other screen. I'll bring it in once it's fully open. Okay, so this is our checkboard app. We just need to click, just click create project. Right, so this is an empty space because we haven't imported anything. I just go back to tabs because this is a rather smallish structure. So I just import everything. Just click connection here. Yep, so once it is imported, you can actually see that all the internal forces, all the geometry will be brought over automatically to checkboard. And you can see that we have these new grouping features which group the connection or node with the same typology together. And so for this example, I'll be designing this, which is the base of the column connected to the concrete. I just click right click open. Then it will open our connection application. It's also opening on my other screen, so I just bring it over. All right, I prepared operations for this. I prepared a template for this, so I just click propose to put back my previously saved templates. Right, for this case, right, because I'm only modeling the part, just the part of the concrete block, so I'm only modeling the stump. Then I just click calculate to check whether the anchor fails or not. Right, so as you can see, the anchors is failed quite badly. So if you go to this check tab, you can see quite a lot of stuff here. For example, you can actually turn on the bolt forces here. You can go to, you can see the contact stresses in the concrete. Then you can see the deform shape of structure, right? And so basically I want to see the detail of why the anchor fails. I just open one of the most utilized anchor, which is this one, A17. Then I just scroll down to the bottom here. You can see that actually the failure is caused by the concrete breakout, which is the cone failure, and the concrete edge failure. So these two cases means we can use reinforcement to actually prevent this failure. Right. So just going back here. Now for in detail, I would like to model the whole foundation structure, which means there's a stump plus there's a pad here. So what I do, I just need to change the make the geometry of this concrete block here bigger, because I want to model everything, right? And then in detail later, I'll show you how to cut this and model this properly. Basically, you just need to rerun again, and then I just go to check tab, and I click this button, which is called RC check. Then we just click RC check, and then you just save it somewhere in your PC. Once you save it, then the detail application will open automatically. Yeah, just wait a while. Right. Then now, as you can see, yeah, all the geometry is transferred automatically. Then I also can see the anchor forces plus the weld forces from the connection applications automatically transferred here. And so if you have multiple load cases, it will be brought here automatically. Right, so first thing that I'm going to do is I'm going to actually cut this concrete block so that it will have a stump plus the bed footing. We go to a model entity here. This is a new features that we release in this version 25. We can add negative volume to cut our concrete, and we also added this cast-in plate in this version to help you model other types of anchoring basically. So I'm going to use a negative volume, right? Then I'm just going to change the shape, then the position as well. Right, so I place it like this. Basically, this is where you want to cut. I place it like this. Then I'm going to copy paste it and just change the surface. So I cut the other side. Oops. Then I copy again. I change the geometry again. Yep. Also the surface and the position. Oopsie. Yep. It is. And then last cut will be for the back height. Change the surface a bit. The Z position. Right. Yeah, so you basically see all these cutters. Now I just need to click operations here. Let me just do this operations, and then I just click cut. So you can see it's now cut by NV1. So you can see in a concrete block is now cut by NV1. Just need to click copy, change it to NV2, NV3, and NV4. Yeah. Then as you can see now, the shape is correct. This is the stump, this is the bed footing, this is the shape that I want. Now we just need to add the reinforcement. Yeah, can change the diameter, change the anchorage type, and the surface, and sorry, need to change this to this. Yeah. Then the edges number. Oops, this one is yep. Then you can change the surface cover and number of rebar itself. Yeah, so as you can see, this is the stirrup for the stump. Then I want to add the main reinforcement for the stump. Just need to copy this, change the surface to surface 11, because as you can see, this is surface number 11. Then you just change the edges. Then I want to extend the first edge and the last edge. Yeah. And the number of layers I want to change to 5, right? Because that's enough. And you just need to copy again for the other direction. Change the surface to number 7. Change this to 143. Right. So as you can see, both direction of the stump is already covered. Then I want to put the reinforcement for the pad footing. For the pad itself, just need to copy this. Yeah, change the anchorage type. Then change the surface to number 4. Change the edges to 1, 2, 3, 4. And remove these edges like this. Change the number of layers and the distance between layer. Right. So I want to put it on the other direction. Then I just need to copy it and change the surface to number 3. Yeah. So as you can see how quickly we can model in the reinforcement inside our pad footing. Now, one last thing is we would need to add the surf weight load case. I just change this to surf weight. Then I add in the surf weight itself. And inside the combination, don't forget to add it in. 1.35, for example, Eurocode. And yeah, I think that's it for our modeling. And one last thing before we run, you go to setting here. Because this is our first run, you can go to mesh setting here and then change this to a bigger mesh. So for the initial run, before you know that this arrangement will work or not, normally I will change this to 5 first for the first run. Once you verify that everything is okay, everything is running, you can change this back to a smaller number. Right, so you just need to click calculate here. But to save up times, I've already prepared the ready run model, right? So once you click calculate and it finish calculating, it will actually show this. This is actually the stress flow. So if I go to this view, you can see this anchor is actually in tension, and you can see the shape of the concrete breakout, which I described in the code previously. Basically, this is in tension, and this side is in compression. So the bending moment is this direction. Yeah, and if you see from the top, you can actually see that these cone or tension forces and then the cone stresses actually will be taken by the reinforcement on the side or distributed to the reinforcement on the side. Yeah, so you can use this to actually see if your model is correct or not. And same thing with the compression, you can see that it is spread into the ground via the bed footing. Right, and then you can see a lot more things. You go to strength here, concrete, you can actually see the stresses of the concrete. If you want to see what is inside, you can also get a section cut, right? I just show you one section cut. I want to cut near the anchor, right? Because I think it will be the one governing. Then just click apply. Yeah, then you can see that, yeah, there's this anchor will be pulled out, and then this concrete will help it spread it to the reinforcement on the sides. Then you can also go to the reinforcement tab here. You can actually see the stresses in MPa here. Blue will be in tension and red will be in compression or minus sign. Yeah, and yeah, here you can see the anchorage calculation. And lastly, you can also see the deformation shape of your pad footing to confirm that your loading and your model is correct or not. Then lastly, once you are satisfied with everything, you can go to report. Then you can click generate here. But I have generated it before. Yeah. So maybe I just click generate again. It's a bit, yeah, but basically you can see a lot of result here in a very detailed result here. And just wait a bit for the report. Yeah, so that's it. The report is generated. Yeah, here you can see ULS result, the concrete stresses, principal stresses, and yeah, you can see each one of the reinforcement, the anchorage calculation, and here we have a very detailed explanation of what the symbol means. So yeah, in here you have the summary table basically saying if your design is okay or not. Yeah. And yeah, each of the reinforcement, each of the anchor, you can see the steel stresses here in a very detailed manner. Yep. So yeah, I think that's it for my demonstration or workshop. Just go back to the slide. Yeah, move on to the next slide, which is a verification. Of course, as an engineer, safety is very important. And yeah, we have our model or solution verified. We have quite a lot of verification done here. You can see that how close it is to the experiments itself. Yeah, and yeah, the experiment, our model is actually 86%. So we have about 15% of safety margin compared to the actual experiment, as you can see on the left here. And on the right here, we model a beam with a sort of a point load, and you can see that comparing experiment and our solver, you can see how close this the result is basically. Yeah. And that's it from my side. And Jan, you wanna summarize for us?
Sure, thank you, Steph. So I'll just take the presentation from now. Can you see my screen? Very good. All right, so thank you for the nice presentation and example how IDEA StatiCa can help designing, anchoring, and using this using reinforcement. So I would just like to summarize. We are giving you multiple anchoring options. So this was just one example, but with IDEA StatiCa detail, you can check post-installed anchors, pre-installed anchors, casted plates, shear lugs, group of anchors. Yeah, so a lot of design options. Also very important to mention that we offer multiple workflows. So the one Steph showed was like export from your final element analysis tool. It was ETABS, but we support a lot of other packages, so like Start Pro, Sub 2000, and Midas and others. So from FEA to IDEA StatiCa connection detailed 3D. But of course, you can start from connection and then to 3D, or even you can start in detailed 3D. No need to run the whole workflow. It's up to you to decide what's the best and fastest way how to get your checks. In terms of checks, so you will have all the ULSec checks of concrete, steel, anchoring. Also, you can see the clear results and generate a very nice report. Also, you can modify the report as per your needs. Sometimes there is no need to have such a long report, just brief one, so it's editable. And currently, we support American code and Eurocode, because this functionality is pretty new, but more local codes are coming. So our plan is to add more and more codes shortly. So if your region is not covered by AIC/ACI or Eurocode, don't worry, it's coming soon because the technology is there, it's working, and it's giving very good results. And was the biggest value for us as engineers. So no more guesswork. So as Steph showed, the approach in code is not 100% clear. So strat and tie, how to do it, etc. Ultimately, we can get safe results and report. It's important to mention that structural engineers are responsible for the safety of the structure. So we want to be sure that our design is good, and also we can save a lot of material because, like, if I remember it correctly, 35% of you mentioned that you would just enlarge the block. Yes, this is the simple way. But in many cases, it's really not needed because there is already a reinforcement the only issue is my current software or my spreadsheet doesn't take into account this reinforcement. So now I have a tool. I can just do this job 10 minutes and I can see that it's working even without enlarging the structure. So this is also very good. Okay, so that's the summary, and now we have some question and answers. So maybe I will ask. So they are coming. There's a lot of coming. Let me pick some of them, and also feel free to add more. Okay, so there are some questions about the recording. Multiple people are asking if there will be recording of this session and upload it on YouTube. Yes, there will be after the webinar. Let's say it will come one day. We will send you an email with link so you can see it on YouTube channel. So you can go through and see what's there. There was also a question if we can model steel insert with shear stud inside the concrete. So maybe this is the shear lock. Maybe Steph, can you share your screen again and show more design options?
Yes, give me 1 second. Yep. Sharing. Yep. So let me get this. Yeah, so on the base plate itself, you can actually change the shear force transfer by shear lock, by friction, or by anchors. And yeah, as I mentioned, you can also model in these casting plates if you have casting plates. Yeah.
Thanks. And what about designing specific anchor, post-install anchor, for example, Hilti or Fisher? Where can we set it? Can you show us, please? So you can see it here, like adhesive anchor and bond strength. These are the factors everyone can edit. Yeah. Very good. Questions? Support the file transfer from Strand 7 and Space Gas.
Yes, we support both software. The Strand 7 and Space Gas both are integrated with IDEA StatiCa. Yeah.
Good, thanks. Also question if there is any specific application of IDEA StatiCa to analyze anchors embedded into rock. Unfortunately not. Currently we support only concrete block. Still there is a lot of things to cover in concrete, but maybe in the future, if there will be a big demand, why not to consider this? There is also a question, why are utilizations always around 99% when reviewing the results? Can we talk a little bit about this, Steph?
Yeah. So yeah, basically this oops, I think I lost my it's here. Yeah, basically it's showing this whereby the anchor forces and the bond stress is compared. That's why you see this 99%. Yeah.
Okay, thanks. And couple more questions. You can share the module to participants. I think we can, not a problem. So those who will like to have a module, please write it there because we probably will not share it to everyone. Oh, there's a lot of questions coming. When can I expect the Austrian concrete code to be included? Good question. So the Austrian code is in next list. If everything will go well, it may be during this year, but we are not promising. Yeah? but we'll try our best. If I have multiple steel elements connected to an RC column on a different faces, how do I approach it using connection and detail apps? Good question. Can we combine it?
Yes, so if we have different faces, right, in connection actually is not covered because there's no reinforcement in there, but you can model two concrete block inside connection application. And then once you import it to detail, you will bring in both concrete block, and inside detail, there's this new functionality which I show you is called the cut. And with this cut, you can actually combine those two concrete block inside detail application. That way you can actually analyze two different faces.
Okay, very good, thanks. And there's also a question if there is any limitation of adding reinforcement. I would say not much limitations. Of course, probably you cannot model any crazy shape, but you are free to model as just showed you, like using our operations. So there is no limit, like we would tell you it's enough or something. Yeah, so it's any crazy shape you can model right now, you can reinforce. All right, so I think it was good about. Sorry, I think it was a lot of questions coming, so we will answer the rest individually. So feel free to ask more, and I'm taking the presenter back to me, moving my screen. So we also have a good offer for you. So whoever is interested, maybe you noticed we are running a campaign for IDEA StatiCa Complete, which includes both steel and concrete functionality. It's both for existing customers and new customers. So if you want to upgrade, that's a great chance, or if you are considering purchasing a license. So if you want to get your quote, we also prepare a poll for you. So you may tell us whether you are interested, and then our resellers in the given territory will contact you with the specific conditions because they may vary a little bit. So if you like it, you can tell us, yes, I want to be contacted, or you already have an access. So just to mention, the access is in IDEA StatiCa editions, steel, or like connection in steel, detail in concrete, complete, or enterprise. So please vote if you want to be contacted. So we will put a priority on this, either new customers or existing customers for upgrade, because now is a great time to get the full package, including this. Okay, so I'm giving you 5 more seconds. Okay. Let me close it and see the results. How big is the interest? So yes, very good, 20%. Yes, you want to be contacted, you are the customer, 26% want an upgrade, 43% already have an access to digital 3D, which is very good, and 12% not interested. So, okay, maybe next time. So thank you for this. And we are going towards the end. Also, the anchoring is a big topic in general, not only for us, but it's also good to mention that we are cooperating with Hilti. I would say most of you know this company, one of the world's biggest producer of anchors and drills and all the machinery. And we are also having a joint webinar with Hilti next week, because the Hilti Process Engineering also works on CBFM method. And if you want to design the particular Hilti anchor, it's also good to know how you can use it in Profis. So there's not so many options for steel itself, but very good for Hilti portfolio. So here's the QR code. We'll be happy to see you there. And the good news is Steph will be there as well. So scan the code, and let's meet again and talk about anchoring more in detail. So it's everything from our side. It was quick, very good, 45 minutes. So thank you for attending, and see you soon on our other webinars. Thank you very much.